Hello, welcome. In this short video, let us look at an example of a Z transform of a truncated infinite series. That is, given the signal x of n is equal to 1 by 2 power n for all values of n greater than or equal to 5 and 0 for n less than 5. So n is an integer. So for values of n greater than or equal to 5, the signal is given by the discrete signal is given by 1 by 2 power n, and it is 0 for all the other values. So that means it will have values something like this. This is 1 by 2 power 5, and then this is 1 by 2 power 6, and then 1 by 2 power 7, and so on. Okay. So this is the signal, and on the left hand side the values are all zeros. So the locations are, the values of n are 5, 6, 7, and so on, and this is the n axis, and on the left hand side 4, 3, and so on. These are all zeros. Okay. So this is the signal x of n. Now our goal is to find Z transform. That means the goal is to find Z transform. So given this signal x of n, which is a truncated infinite series, that means it has values only from 5, and then the values keep decreasing, and they go up to infinity, and now we have to find the Z transform. So now let us look at the solution. So by definition, x of z for any given signal is n is equal to minus infinity to plus infinity x of n z power minus n. So since the signal is defined only from 5, and everything before 5 is 0, so the Z transform definition can be modified as follows. X of z is equal to summation n is equal to 5 to infinity, and x of n is 1 by 2 power n, and z power minus n. So that is the definition of Z transform for this signal. Now this summation can be rewritten as follows. Summation is equal to, just we complete the summation first, that is from n is equal to 0 to infinity 1 by 2 power n z power minus 1. So this is a complete infinite series, and then we subtract the terms that are included to achieve this complete summation, or to get this complete summation. So what we do is we subtract the rest of the terms, that is n is equal to 0 to 4. These are the terms that were added here, so we have to subtract them. So 1 by 2 power n z power minus n. So these terms originally were not included in the definition of x of n, so we have to subtract them. Now we have to evaluate these two sums, and then the difference is the required Z transform. So the sum 1, that is summation n is equal to 0 to infinity 1 by 2 z inverse whole power n, is basically an infinite series, and it is defined by 1 by 1 minus 1 by 2 z inverse, provided that z inverse 1 by 2 modulus of 1 by 2 z inverse is less than 1. So in other words, mod z is greater than 1 by 2. So that is the ROC for this particular sum. Now let us look at the sum 2. Sum 2 is summation n is equal to 0 to 4 1 by 2 z inverse z inverse whole power n. So this is a finite sum. So its definition is given by 1 minus half of z inverse whole power the number of terms here, that means 5, and then 1 minus 1 by 2 z inverse. Here we are using the following formula. Summation k is equal to 0 to L alpha power k is equal to 1 minus alpha power L plus 1, that is there are L plus 1 terms, divided by 1 minus alpha. So this is the definition of a finite sum where alpha is a value absolutely less than 1. So for this one we have then we apply this formula, we get this result. Now the overall z transform x of z is the difference of these two results. So for this z transform also, this sum also, the ROC is the same region. So the overall z transform x of z is equal to 1 by 1 minus 1 by 2 z inverse, that is the result from sum 1, minus the second one, that is 1 minus 1 by 2 z power minus 1 whole power 5 divided by 1 minus 1 by 2 z inverse. So upon simplification, we can write that x of z is equal to 1 by 32, that is 1 by 2 power 5, which is 1 by 32, and the ones go away. So and then in the numerator we have z power minus 5 divided by 1 minus 1 by 2 z inverse. And the ROC is given by mod z greater than 1 by 2. So now let us just visualize the ROC. So this is the circle of radius 1 by 2. This is 1 by 2. So ROC is the region outside this circle. So this is the ROC. So that is a region outside the circle of radius 1 by 2. This is the ROC in the z plane. So to summarize, we have a signal that is a truncated infinite series which is given by 1 by 2 power n for all values of n greater than or equal to 5, and it is 0 for other values of n. So that is, it starts at the value 5 and the starting value is 1 by 2 power 5, that is 1 by 32, and then it keeps decreasing as a function of 1 by 2 power n. And then our goal was to find out the z transform. So the original z transform starts at minus infinity, but since the signal starts at 5, the summation is modified such that it starts at n equal to 5 and goes on to infinity. So summation is n equal to 5 to infinity 1 by 2 power n z power minus n. So to apply the infinite series formula, so we just add those 5 terms to complete the sum, and then we subtract the same terms. So for the first summation, the z transform is very simple, and it is given by 1 by 1 minus 1 by 2 z inverse. So this is the z transform or the formula for infinite series. And then we use the definition for finite number of terms, that is summation of finite number of terms for a geometric series where alpha is absolutely less than 1. So in that case we have this result, and then the overall z transform is the difference of these two. And here it is very simple. Upon simple algebra, we get that x of z is equal to 1 by 32 into z power minus 5 by 1 minus 1 by 2 z inverse. And clearly this is a delayed version of the the original signal 1 by 2 power n for all values of n starting from 0, and the delay is represented by z power minus 5. So the ROC is a region outside a circle of radius 1 by 2 on the z plane. Thank you.